Friends, welcome to the class. Today we will discuss some questions on trigonometry. Already we have discussed the various concepts, identities of trigonometry. Now we will discuss some more questions. Friends, you will come across some questions which already appeared in previous board exams, and it will be helpful for you from the exam point of view and also to get more clarity on the concept. So let's start. Given that tan A minus B equals to tan A minus tan B whole divided by 1 plus tan A into tan B. Find the value of tan 15 degree. So it is given that tan A minus B equals to tan A minus tan B whole divided by 1 minus tan A into tan B. Now we know that tan 15 degree equals to tan 45 degree minus 30 degree. So we can write in this form tan A minus B. So tan 15 degree can be written as tan 45 degree minus tan 30 degree whole divided by 1 minus tan 45 degree into tan 30 degree. Now putting the values, we get tan 15 degree equals to 1 minus 1 by root 3 whole divided by 1 plus 1 into 1 by root 3, because tan 45 degree equals to 1 and tan 30 degree equals to 1 by root 3. Or taking root 3 as the LCM, we get it as root 3 minus 1 whole divided by root 3 whole divided by root 3 plus 1 by root 3. Or cancelling root 3 in both numerator and denominator, we get tan 15 degree equals to root 3 minus 1 whole divided by root 3 plus 1 is the answer. If root 3 into tan theta equals to 3 sin theta, find the value of sin square theta minus cos square theta. So it is given root 3 tan theta equals to 3 sin theta, or we can write tan theta in terms of sin theta by cos theta. So root 3 into sin theta by cos theta equals to 3 sin theta, or root 3 into sin theta by cos theta minus 3 sin theta equals to 0, because we are taking 3 sin theta to the left hand side. Or taking root 3 sin theta common, it is root 3 whole into 1 by cos theta minus root 3 equals to 0. So on equating or on simplifying, we get it is root 3 whole into 1 minus root 3 sin theta, 1 minus root 3 cos theta by cos theta equals to 0. This implies root 3 sin theta whole into 1 minus root 3 cos theta equals to 0. Now on equating in both the sides, we get sin theta equals to 0 and cos theta equals to 1 by root 3. We know that sin theta equals to square root of 1 minus cos square theta. So putting the value of cos square theta, that means cos theta, from here 1 by root 3, it is 1 minus 1 by root 3 whole square, which is nothing but 1 minus 1 by 3, or it is square root of 2 by 3. Now sin square theta minus cos square theta can be written as sin square theta minus 1 minus sin square theta, because cos square theta is nothing but 1 minus sin square theta as per the trigonometric identities. So it can be written as 2 sin square theta minus 1, or when sin theta equals to 0, we get 2 sin square theta minus 1 equals to minus 1, because the value of sin theta is 0, and when sin theta equal to root 2 by 3, 2 sin square theta equals to 2 sin square theta minus 1 equals to 1 by 3. Hence, the value of sin square theta minus cos square theta, either minus 1 or 1 by 3, is the answer. If m sin theta plus n cos theta equals to p, and m cos theta minus n sin theta equals to q, prove that m square plus n square equals to p square plus q square. So it is given that m sin theta plus n cos theta equals to p, and m cos theta minus n sin theta equals to q. So on squaring, we get m sin theta plus n cos theta whole square equals to p square, and m cos theta minus n sin theta whole square equals to q square. Or on adding, we can write it as m sin theta plus n cos theta whole square plus m cos theta minus n sin theta whole square equals to p square plus q square. Or on expanding, we get it as m square sin square theta plus n square cos square theta plus 2mn sin theta cos theta plus n square cos square theta plus n square sin square theta minus 2mn sin theta cos theta equal to p square plus q square. Here 2mn sin theta cos theta and minus 2mn sin theta cos theta can be cancelled, and in both these cases we can take m square common, m sin square theta and m cos square theta. Likewise, we can take n cos square theta and n sin square theta. We can take n square common in these two cases. Let's see. So it is m square into sin square theta plus cos square theta plus n square into sin square theta plus cos square theta equals to p square plus q square. But we know sin square theta plus cos square theta equals to 1. So we are getting m square plus n square equal to p square plus q square. Hence proved. If A, B and C are interior angles of triangle ABC, so that tan square B plus C by 2 equal to cosec square A by 2 minus 1. So it is given that A, B and C are the interior angles of triangle ABC. That means sum total of A, B and C equals to 180 degree. So we can write it as A plus B plus C whole divided by 2 equals to 180 degree by 2, which is nothing but 90 degree. Now B plus C by 2 equals to 90 degree minus A by 2, or tan of B plus C by 2 equals to tan of 90 degree minus A by 2, which is nothing but cot A by 2. So on squaring both the sides, we get tan square B plus C whole divided by 2 equals to cot square A by 2. But what is cot square theta? It is cosec square theta minus 1. So cot square A by 2 can be written as cosec square A by 2 minus 1. Hence proved. If cos alpha by cos beta equals to m and cos alpha by sin beta equals to n, prove that m square plus n square whole into cos square beta equals to n square. So it is given that cos alpha by cos beta equals to m and cos alpha by sin beta equals to n. So let's go to the left hand side. M square plus n square whole into cos square beta. Putting the values of m and n in the respective places, we can write it cos alpha by cos beta whole square plus cos alpha by sin beta whole square whole into cos square beta, or which is nothing but cos square alpha by cos square beta plus cos square alpha by sin square beta whole into cos square beta. Now if you multiply cos square beta can be cancelled, and cos square alpha it will remain as it is. Let's see. So on multiplying, we are getting cos square alpha plus cos square alpha cos square beta whole divided by sin square beta. We can take cos square alpha common, or it can be written as cos square alpha whole into 1 plus cos square beta by sin square beta. In the bracket, we can take sin square beta as LCM, or it is cos square beta whole into sin square beta plus cos square beta whole divided by sin square beta. But sin square beta plus cos square beta is nothing but 1. So we are getting cos square alpha by sin square beta whole into 1, which is nothing but n square, because n is cos alpha by sin beta. So n square is cos square alpha by sin square beta. This is right hand side. Hence proved. Prove that cot A plus cosec A minus 1 whole divided by cot A minus cosec A plus 1 equals to 1 plus cos A whole divided by sin A. So left hand side is cot A plus cosec A minus 1 whole divided by cot A minus cosec A plus 1, or you can write it as this 1 can be written as cosec square A minus cot square A. So it is cot A plus cosec A minus cot square A, cosec square A minus cot square A whole divided by cot A minus cosec A plus 1, or on simplifying A square minus B square, it can be written as A plus B into A minus B. So this cosec square A minus cot square A can be written as cosec A plus cot A into cosec A minus cot A. Now in both the cases, cosec A plus cot A can be taken as common. So on taking common, we get cot A plus cosec A whole into 1 minus cosec A minus cot A whole divided by cot A minus cosec A plus 1. If we open the bracket, we get is cot A plus cosec A whole into 1 minus cosec A plus cot A whole divided by cot A minus cosec A plus 1. But in numerator and denominator, we got the same factor, so we can cancel it out, or we are getting it as cot A plus cosec A. Now what is cot A plus cosec A? We can write it as cos A by sin A plus 1 by sin A. Now sin A can be taken common denominator for both the cases, or it is nothing but 1 plus cos A whole divided by sin A, which is the right hand side. Hence proved. If sec A equals to 17 by 8, so that 3 minus 4 sin square A whole divided by 4 sin square A minus 3 equals to 3 tan square A whole divided by 1 minus 3 tan square A. So the given data is sec A equals to 17 by 8. We know tan A equals to square root of 6 square A minus 1, or it is nothing but square root of 17 by 8 whole square minus 1, which is nothing but 15 by 8. Now left hand side is 3 minus 4 sin square A whole divided by 4 cos square A minus 3, or on dividing cos square A in both numerator and denominator, we get 3 sec square A, because 3 by cos square A is sec square A, and 4 sin square A by cos square A is 4 tan square A whole divided by this cos square A gets cancelled, minus 3 by sin cos square A, which is another 3 sec square A. Now putting the values, we get 3 whole into 17 by 8 whole square minus 4 into 15 by 8 whole square whole divided by 4 minus 3 into 17 minus 8 whole square, which is nothing but 33 by 611. Let this is first equation. Now come to the right hand side. 3 minus tan square A whole divided by 1 minus 3 tan square A. Already we got tan A to be equals to 15 by 8. Now putting the values, we get 3 minus 15 by 8 whole square whole divided by 1 minus 3 into 15 by 8 whole square, which is nothing but 33 by 611, equation 2. So in both equation 1 and equation 2, we get the same result. That means we can say left hand side and right hand side are the equal. So from equation 1 and 2, it is clear that 3 minus 4 sin square A whole divided by 4 cos square A minus 3 equals to 3 minus tan square A whole divided by 1 minus 3 tan square A. Hence proved. Prove that 1 by sec x minus tan x minus 1 by cos x equals to 1 minus 1 by cos x minus 1 by sec x plus tan x. So the left hand side is 1 by sec x minus tan x minus 1 by cos x, or 1 can be written as sec square x minus tan square x. So we can write it as sec square x minus tan square x by sec x minus tan x minus cos x, or a square minus b square. It can be written as a plus b into a minus b, that means sec x plus tan x whole into sec x minus tan x by sec x minus tan x. So these two factors gets cancelled, or we are getting it as sec x plus tan x minus 1 by cos x. But again, 1 by cos x is nothing but sec x. So this sec x and this one gets cancelled. So we are getting tan x, because 1 by cos x equal to sec x. Now let's come to the right hand side. 1 by cos x minus 1 by sec x plus tan x, or it can be written as 1 can be written as sec square x minus tan square x. So on further expansion, we get 1 by cos x minus sec x plus tan x. Again, 1 by cos x is nothing but sec x. So sec x is 1 by cos x and sec x gets cancelled. We are getting tan x. That means from equation 1 and 2, we are getting right hand side to be equal to left hand side. Hence proved. So we can write 1 by sec x minus tan x minus 1 by cos x equal to 1 by cos x minus 1 by sec x plus tan x. Prove that 2 sec square theta minus sec square sec to the power 4 theta minus 2 cosec square theta plus cosec to the power 4 theta equal to cot to the power 4 theta minus tan to the power 4 theta. So the left hand side is 2 sec square theta minus sec to the power 4 theta minus 2 cosec square theta plus cosec to the power 4 theta. We're taking sec square theta in the common in the first two factor, we get sec square theta minus 2 minus sec square theta, and taking cosec square theta common in the second two factor, third and fourth factor, we get cosec square theta minus 2 into 2 minus cosec square theta. So it can be written as sec square theta minus 2 minus 1 minus tan square theta, because sec square theta is 1 plus tan square theta, as it is minus 6 square, so it can be written as 2 minus 1 minus tan square theta. And likewise, this cosec square theta minus 2 whole into 2 minus 1 minus cot square theta. Or 2 minus 1 is 1, so it can be written as sec square theta whole into 1 minus tan square theta minus cosec square theta whole into 1 minus cot square theta. Again, sec square theta is nothing but 1 plus tan square theta, and cosec square theta is nothing but 1 plus cot square theta. So here we get 1 minus tan square theta whole into 1 plus tan square theta and minus 1 minus cot square theta whole into 1 minus cot square theta. So it is a minus b into a plus b. So it is of the form a square minus b square, that is 1 square minus tan square theta whole square, which is nothing but tan to the power 4 theta, minus 1 square minus cot square theta whole square, which is nothing but cot to the power 4 theta. So on opening the bracket, we get 1 minus tan to the power 4 theta minus 1 plus cot to the power 4 theta, or it is nothing but cot to the power 4 theta minus tan to the power 4 theta, which is nothing but the right hand side. Hence proved. Prove that cosec a minus sin a whole into sec a minus cos a equals to 1 by tan a plus cot a. So the left hand side is cosec a minus sin a whole into sec a minus cos a, or cosec a can be written as 1 by sin a minus sin a whole into 1 by cos a minus cos a, which is nothing but 1 minus sin square a divided by sin a whole into 1 minus cos square a by cos a. But 1 minus sin square a is cos square a and 1 minus cos square a is sin square a. So it can be written as cos square a by sin a whole into sin square a by cos a. So the denominator sin a and cos a gets cancelled, or we get sin a into cos a. Now in the right hand side, 1 by tan a plus cot a, or it can be written as 1 by sin a by cos a plus cos a by sin a, or it can be written as 1 by sin square a plus cos square a whole divided by sin a cos a. Now this sin a cos a, the numerator, it can be taken as the denominator, it can be taken as the numerator, so we can write it as sin a into cos a by sin square a plus cos square a by 1, or it is nothing but sin a into cos a. That means left hand side equals to right hand sides. Hence proved. Friends, here is a few questions, few examples, but these questions are not enough. Friends, practice more and more such questions, and in case you come across any difficult question, feel free to share your question with me. It will be a pleasure for me if I can help you out in solving your doubts, in solving your question. So this much for today's class. Thank you.